Current is the flow of electric charge around a circuit. These electrical charges are called electrons, which are negatively charged. Current flows from negative to positive, however the conventional direction of the flow of current is positive to negative. This was chosen by Benjamin Franklin before the electron was discovered.
Current will only flow through an electrical component if there is a potential difference and the circuit is complete. Potential difference, which is measured in volts, is the driving force which pushes the charge around. Resistance is anything that slows the flow down and is measured in ohms. The current flowing through a component depends on the potential difference across it and the resistance of the component. Generally speaking, for a given component, the higher the potential difference, the higher the current will be, and the greater the resistance, the smaller the current that flows. The equation for charge is current times time.
Potential difference is the energy transfer per coulomb of charge that passes between 2 points in an electrical circuit. To calculate energy transferred, charge moved and potential difference, you can use this formula. Energy transferred equals charge moved times by potential difference. Potential difference is sometimes called voltage, and 1 volt is 1 joule per coulomb. Resistance, potential difference and current can be put into the formula potential difference equals current times by resistance. And as a formula triangle, it is V over I times R. When an electrical charge flows through a component, it has to do work against resistance. Work done equals energy transferred. Some of this energy is transferred usefully, however some of it is dissipated to the thermal energy stores of the component and its surroundings.
When a current flows through a resistor, the resistor heats up. This happens because the electrons collide with the ions in a lattice shape inside the resistor. This then gives the ions energy, which causes them to heat up and vibrate. If the resistor gets too hot, then no current will be able to flow. The more the ions vibrate, the more difficult it is for the electrons to get through the resistor. LDR is short for light dependent resistor. An LDR is a resistor which is dependent on the intensity of light. With a bright light, the resistance falls, and when in darkness, the resistance is at its highest.
The resistance of a thermistor decreases as the temperature increases. A thermistor is a temperature dependent resistor. In hot conditions, the resistor drops, and in cool conditions, the resistance goes up. Thermistors make useful temperature detectors.
Hello and welcome to today's science video. Today we're going to be discussing series circuits and parallel circuits. First, before we get into it, we need to be able to understand and know what a series circuit is and what a parallel circuit is. So obviously everybody knows what a circuit is. However, the difference is that a series circuit is just one whole thing, basically like a circle, starts and ends at the same point initially, if you think about it like that. However, in a parallel one, you can have different columns, which is why it's parallel, because they're opposite each other. So, what's the difference between the two and how do they function differently? Well, for example, if I had 4 lamps in a series circuit and one of them broke, all of them would stop working. On the other hand, in a parallel circuit, if one lamp stopped working, the others would still function perfectly fine. And also in parallel circuits, each component is separately connected.
Most things are connected in parallel. For example, in household electrics and in cars. This is because you have to be able to switch everything on and off separately.
In series circuits, the different components are connected in a wire end to end. Adding a resistor to a parallel circuit reduces total resistance. However, if we add a resistor to a series circuit, it increases the total resistance. In a series circuit, the total resistance of 2 components is just the sum of their resistances. The bigger a component's resistance is the bigger its share for potential difference. So bigger is always more. In a series circuit, I can apply ammeters, volts, and lamps.
Power is simply how quickly energy is transferred. The formula for power is energy transferred over time, or P equals E over T. Appliances are often given a power rating. They're labelled with the minimum safe power that they can operate at. You can usually take this to be their maximum operating power. The power rating tells you that the maximum amount of energy transferred between stores per second. Power also depends on current and potential differences. Electrical power is current times potential difference. Electrical power is measured in watts, current is measured in amps, and potential difference is measured in voltage.
Thank you so much for watching our video. Have a nice day.
1, 2, 3. Okay.
Hi, welcome to my... Can we restart?
Yeah.
Let's start again.
No, you just have to stop from when you start laughing.
Okay, there's something with editing.
Yeah, but if they edit, I know. I'll just say the same thing twice.
Hello and welcome to today's science video.
We're starting again.
It's okay, I want to go quicker.
It sounds so sad.
It's okay, we can edit it.
Okay, yalla.
What is he doing?
You can cut this out.
We're just edit that.
On the other hand, if I had a parallel graph, I mean... On the other hand,
This
can
thing's
you
falling
stop?
down. It's falling down, man. I'm not doing it for fun.
For fun? You're not having me.
That's perfect. Zayn, come a little bit. And no, Zayn.
Oh, you go away. What's the problem?
Okay.
I need to compose myself.